Hello again, algebra students, advanced pre-algebra students, math students. Today we're going to continue talking about functions. We're getting close to like the middle of the chapter. We're going to be taking a quiz by the end of the week. But when we talk about linear functions, first of all, we know what a function is by now. Each input has exactly one output. And it's linear, that means it's going to be a straight line. But I do want you to notice one thing that they've got right here. It says a linear function is a function whose graph is a non-vertical line. Think about if that makes sense for why it can't be vertical. Remember our vertical line test? Any other straight line that I would graph. So if I had my x and y coordinate plane and I have this line, it's fine. It would pass the vertical line test, right? If I would draw a vertical line, I can only hit that once. However, if I have my coordinate plane and I have a vertical line as my, it's not going to work, but if I'm trying to see if that's a function, and then I use my vertical line test, that vertical line test would touch that in lots and lots of places, not just one. So that's why it can't be a vertical line. It has to be non-vertical. I am not going to try to trick you with this, but I did want to point that out so that you're understanding why it can't be vertical. So when we're doing this, we are writing equations and it's going to be in slope-intercept form, and we have done a lot of that already recently and from a long time ago. So we're going to be writing equations from graphs and from tables and sometimes from other situations as well. You've seen these exact slides before. So to write the equation of a line, you need to know the slope and the y-intercept. In a graph, you know that you can find the slope just by counting. In this one, the rise or run, it is a negative slope. It's going downhill, but to go from this point to this point, it even says down 3 units and over 2, but remember I would do this 1, 2, 3, and then over 2. So this slope is going to be a negative 3 over 2. The y-intercept is just where it crosses the y-axis, and you can even see that right here. Let me make that point even a little bit bigger. Right there, it's at negative 1. So my equation would just be y equals negative 3 over 2x minus 1 or plus a negative 1. But again, not new. You have done lots of this stuff. Now, this is not a vertical line. This is a horizontal line. It does have a slope of 0. Think about Mr. Slope Guy's mouth. That's what this is. It goes up and down 0, but it goes sideways however many you want to go. In this case, it's going sideways 3 between the 2 points that they've got graphed on here. Right here, it's at negative 3, 4, and here it's at 0, negative 4. I just traced over it in that green so you could actually see it a little bit better, so it would kind of pop out. But this slope, again, is 0. So I need to make sure that when I'm getting this, the slope is going to be 0. The y-intercept, though, is at negative 4. So when I write this equation, I would start with something like y equals 0x minus 4, but we can clean that up, right? 0 times anything is 0, and 0 minus 4 is going to be negative 4. So this answer would be A, y equals negative 4. We've taken a look at these kind of graphs before, by the way. Since this is never going to touch the x-axis, and there's no x in the equation, that should be kind of the hint that helps you remember that. I feel like I skipped over one, but I guess not. If I give you graphs like this, you should be able to find the slope, find the y-intercept, give me the equation, right? The slope of this line is, we're going up. I have to be a little careful here with the points that they've got labeled. Notice that they're counting by 2's for each square going up and down and 1 going sideways. I don't really like that kind of thing, but I do think that it's important that we're aware of the fact that they can do that sometimes. So to go from here to the origin, for instance, this is really going up 3, right? Because this is at negative 3, I'm going to go up 3. I can even do that. And over 1. Up 1, 2, 3, and over 1. So my slope would be 3 over 1, which is just 3. And the y-intercept is 0. So this equation is just y equals 3x. You can say plus 0 if you want to, but you don't have to. This is very similar to the last slide that we just looked at. The slope of this is 0. I'm going up and down 0 and sideways 1. Sideways 1, sideways 1. So slope of 0. The y-intercept is at 2. So this equation, I could write y equals 0x plus 2. But 0 times anything is 0. 0 plus 2 is just y equals 2 for our equation. If you have a table, you don't need to graph it to be able to get this information. We can find the slope. The slope is the change in y over the change in x. We can find the y-intercept in a table. And again, we've done all of this stuff. So if I look at what I've got here all worked out already is from these two ordered pairs right here. So I'm going to say what happens to the y's to go from 7 to 5? That's going up by 2. And the x is going up by 1. So my slope is just going to be 2. Okay, my brain not quite working here. To go from 7 to 5 is going down 2. So it's a -2, and that's a -2. Sorry about that. All right, the y-intercept is just when the x is 0. The x is 0 because we're not going sideways at all. I need to be able to go straight up or down onto the y-axis. And that's going to happen right here. So the y-intercept is going to be at 5. So if I have, my slope is -2 and my y-intercept is 5, my equation is just going to be y equals -2x plus 5. Here's more tables. I don't like tables that go sideways as much as when they go up and down, just because I find students that make mistakes when we have these kind of problems. So I just want to make sure that you're aware when we're finding our slope, remember it's always the change in y over the change in x. So what's happening with my y's? To go from 5 to 7 to 9 to 11, this one is actually increasing by 2. And the x is also increasing, but this time only by 1. So my slope is 2. My y-intercept is when the x is 0. So it's right here. My y-intercept is 5. So my equation is going to be y equals 2x plus 5. For number 4, the slope, change in y. What's happening to my y's to go from -1 to -2 to -3 to -4? That's actually decreasing by 1. But the x's are going -2 to 0. That's up 2, up 2, up 2. So my slope is going to be a negative slope. One's going up, one's going down. That gives me a negative slope. My y-intercept is when the x is 0. So it's going to be at -2. So my equation is y equals -1/2 x minus 2. And again, if you've got graphs, this should be pretty easy. The first one has a negative slope. It is just counting by ones in each direction, which is nicer for us. The slope is going down 1, 2, 3, and over 1, 2, 3, 4. So -3/4 for my slope. The y-intercept is starting right here at -2. So my equation is y equals -3/4 x minus 2. Now you may not even need to write this stuff down because we're finding that information and then it just goes right into the equation. So in number 2, let's just write the equation. Y equals the slope. This one's going uphill, goes up 1 over 1, 2, 3, 4. So my slope is 1/4. Get the x in there and the y-intercept is right here at 3. Some more tables. And when I do this, change in y. Going up 1, up 1, up 1. Going up 1, up 1, up 1. All right, my slope is just 1. My y-intercept is 4. So my equation is y equals 1x plus 4. Or you know that we can just write that as y equals x plus 4. And for number 4, the slope first. The y's are going up by 2, up by 2, up by 2. The x's are going up 3, up 3, up 3. So my slope is 2/3. The y-intercept, now don't get tricked because I've got 2 different zeros here. When the x is 0, at tells me the y-intercept. So my equation will be y equals 2/3 x plus 2. Here I've got two different functions that I want to be able to compare. So this is the earnings of a nighttime employee working, x is the number of hours, are represented by that equation, y equals 7.5x plus 30. So what's really happening in here is the $30, since it's a nighttime employee, not everybody likes to work at night. So they might say, hey, I'll give you $30 just for showing up to work. That's the plus 30 part. And then the 7.5, that's really their rate of pay. That's how much they get paid per hour, $7.50 per hour. We've got this table that shows a daytime employee, and we've got for each hour how much money they've made. Which one has a higher hourly wage? Well, looking at the slope of the daytime employee, it's going up by $12.50 for every hour. So the slope for this person is $12.50, or the rate of pay, they get paid $12.50 per hour. The nighttime employee only gets $7.50 per hour. So that means that the daytime employee has a higher hourly wage. And that might be, again, that $30 is because some people don't want to work at night, but in whatever business this is, maybe there's not as much to do at night. Maybe they don't have to get paid as much at night. They might have more free time, but they need that $30 to have an incentive to get people to come in and work a night shift. The day shift might be more busy, and that's maybe why they're getting more per hour. So for part B, it says write a linear function that relates the daytime employee's earnings to the number of hours that they work in the same coordinate plane. We're going to graph these. Okay, so let's just write this equation. This person is getting $12.50 every single hour. There's no like, hey, you showed up for work, you get money. So the equation for the daytime employee is going to be y equals, I'm just going to write 12.5 instead of 12.50, but that's how much they get paid for every single hour. So when I graph both of those, you can see the nighttime employee and the daytime employee. The nighttime employee starts with more money. They're starting at 30 for their y-intercept, but their line isn't as steep because they don't get paid as much per hour. The daytime employee, they don't get paid just for showing up for work. They start at $0, but they get $12.50, which is a little bit more. That's why their line is steeper. So if I'm looking at this graph, that means that right here, they make the same amount of money. If you're going to work 6 hours exactly, it doesn't matter if you want to do the nighttime shift or the daytime shift. However, if you know you're going to work less than that or more than that, you might want to decide which job is better for you. If you know you're going to work an 8-hour shift, well, for 8 hours, the one that's better is right here on the red line for the daytime employee. They're getting more per hour. It's past that 6 hours. If you know you're only working part-time and you're only going to work, let's say, a 4-hour shift, for 4 hours, the better pay is that nighttime employee. And it's because of the rate, the slope of the line, and the y-intercept for where they started. So now, what if the manager, got these different employees, earns $15 per hour and they get a $50 bonus? And manager B, this other person, they just have their line graphed there already. So which one has a higher hourly wage? If we look at manager B, for 3 hours of work, they make $75. That means that point right there is telling me that they are making $25 per hour. And manager A is only making $15 per hour. So the manager that's getting the higher hourly wage, B. The next question says, after how many hours does manager B earn more money than manager A? So manager A, if I would graph manager A's information here, they start at $50. And then here's where it's a little bit tricky because I've got go up $15 for every single hour. But that would be, let me see here, if I would go 4 times, yeah, let's see, just trying to find a nice spot. I know that there's a nice spot in here. For 5 hours, that'd be $75 that we could add on to the 50, which would be $125. That would be right there. So if I would graph this line, so manager A is above manager B for a while because it takes a bit to get caught up from that extra $50 that they got for a bonus. But after 5 hours, at 5 hours, they're exactly the same. After 5 hours, manager B's line is going to be steeper or higher than manager A. So today you've got a worksheet to do with some of these same kind of things and writing equations. There's an answer key for you, and then there's also going to be a learning check in Schoology. If you need any help, let me know.